In this video, we'll do a couple of equations that are quadratic in form, meaning they're not quadratics, but we can make substitution and treat them like a quadratic. So here we go. So one thing that you might notice about this particular first example is that the 4x plus 3 is visible, or is there here and also here. So one approach to this would be to actually FOIL this out and distribute here, and then collect like terms, and then solve the resulting quadratic. Another thing that we often do is we make a substitution. So in this case, I am going to let u equal 4x plus 3, because I notice that's the thing that's there twice. Now, make sure that you're writing down your substitution so that the reader knows what's going on. If you don't do that and all of a sudden this u appears, they're not going to know what that u means. So in this particular case, when we make the substitution, we'll have u squared minus 7u plus 12 equals 0. So this is a pretty basic quadratic that we can factor as u minus 3 and u minus 4. So we can solve and get u is 3 and u is 4 using the zero product property. So all I've done there is set each one of these factors equal to 0. Now keep in mind that was u. So I am going to take these u values and resubstitute. So I'm now going to say 3 is 4x plus 3, and also 4 is 4x plus 3. And so if I solve these, I end up with x is 0, and x is 1/4. And so I still get two answers, but by making that substitution, I have simplified things for myself. So this one was pretty straightforward. They can look a little more complicated. Let's take a look at x to the 4th minus 7x squared plus 12. So I notice, I'm going to rewrite this, I notice that this is x squared minus 7x squared plus 12 equals 0. So you may want to make a substitution. You should notice that you have this x squared. So I'm going to let u be x squared. So once I make my substitution, I'll have u squared minus 7u plus 12. And I guess I didn't make a great example because this factor is exactly the same. U minus 3 and u minus 4. So I get 3 and 4. Now those are u values. So when I resubstitute, I'm going to plug the 3 and the 4 in. So I'm going to say 3 equals x squared and the 4 equals x squared. And to solve, I'm going to take the square root from each side. Remember that when you do that, you have to take both the positive and the negative root. So anytime you're putting the square root into the equation, you have to take both the positive and the negative root. So in this case, we get plus or minus root 3 and plus or minus 2. We actually get 4 answers. So unlike the first one, I did have the option of multiplying that out. I can't do that here. So the best way to approach this one is to make a substitution. All right, let's look at one more example. What do you think you would substitute here when I have x to the 2/3 plus x to the 1/3 equals minus 1? Well, first of all, if it's quadratic in form, it has to be set equal to 0. So I am going to move that 1 over, and I'm going to rewrite this as x to the 1/3 squared plus 2x to the 1/3 plus 1 equals 0. Again, I hope that you notice that we have the x to the 1/3 in two different spots. So I'm going to let u equal x to the 1/3. So I'm going to have u squared plus 2u plus 1 equals 0. So does this factor? Two things that multiply to 1 have to be 1 and 1. So u plus 1 and u plus 1 would get me. And so I just get u equals -1. Now I'm going to resubstitute. So I'm going to take this u equals -1 and plug it in here. -1 equals x to the 1/3. So I wrote a little note up here. When you have a fractional exponent, remember that the denominator becomes your index. So in this case, we get -1 is the cube root of x. This is a radical equation like we talked about previously. So we're going to raise both sides to a power. And we'll get -1 equals x. Okay, that concludes this video on equations quadratic in form. Thank you.